How can I read data from a text file into an array? Now that I have all my data in an array, do I still have to use loops? How do I process an array that isn't full? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 41st video in the Introductory Programming in Java full course and the second video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. In the last video, we introduced the array, a data structure that allows you to store a number of values of one type in one variable. Today we're going to learn how to fill an array from a text file, and we'll review some common looping algorithms that we must still use when processing data stored in an array. Let's get right into it. I've created a text file, which is a simple list of numbers called numcountrieslegal.txt. These values are taken from our World in Data in the Human Rights section from the Number of Countries Protecting Core LGBT+ Rights table. These values are the number of countries where homosexuality is legal from 1950 through 2019. I chose this data because these are rights that are currently being eroded in my country, the United States, as we slip backwards in our support for human rights. Denying the basic human rights of other human beings comes at great cost to us all. You might remember that the father of theoretical computer science, Alan Turing, was persecuted for his homosexuality, after his work contributed enormously to winning World War II. We'll never know what Alan Turing's early death denied the world and our field. Let's talk about text files. Recall that a text file is a file that can be interpreted according to a text encoding, such as UTF-8, a character encoding that can represent Unicode as well as ASCII characters. A text file contains only text characters and no other information. For example, there's no formatting information or images, just characters. What I have here is a program that opens our file of integers, reads each integer, and prints it to the console. Let's briefly review how this program is reading from a file before we modify it to read from the file into an array. First, I want to note that in Eclipse, the text file needs to be in the project folder, not the SRC folder or the package folder. You can always move a file by right-clicking on it and choosing Refactor Move. We're using the File and Scanner classes. We first create the file object by passing the name of the file to the constructor on line 14, data file equals new file numcountrieslegal.txt. A file object is a liaison between the operating system and our program. We then check if the file exists by asking it if it exists on line 15 if datafile.exists. And if it does, we will execute the rest of the code in the program. We create a scanner by passing the file reference variable to the scanner on line 16, file scanner equals new scanner data file. Creating a scanner by passing a file reference can throw a file not found exception. We must add that throws clause to the main method header. In the intermediate Java videos, we'll learn more about exceptions and ways to handle them other than throwing. Once we've created the scanner, we loop over the file with the loop entry condition filescanner.hasNext. In the loop body, we read the next integer from the file and print it. Once we're done reading from the file, we close the scanner. Now let's modify this program to read the values from the file and store them in an array. The first question you're probably asking is, what size should the array be? Do we know in advance how large the file is? And this is the main disadvantage of arrays. We must declare a size for them, and then we're stuck with that size. So if it turns out there are more values in the file than we allocated space for, we won't be able to read them all. For this example, let's imagine we've spoken with the client for this program, and they've told us that there will be no more than 50 values in the file. I'm going to make that a constant. Final int max values equals 50. And I'll declare an array for our values, int value array. you'll see that I'm going to need another variable, a counter variable to index into the array. So I'm going to declare that now, int count. Once we've confirmed that the file exists, I'll create the array, value array equals new int max values. And I'll initialize count to 0. Count now references the first location in our array. Remember, that will have been initialized with all 0 values. Now we want to store the data from the file in the array, starting at location 0. In our loop, rather than reading from the file into a most recent holder variable, printing it, and then replacing the value in the most recent holder variable the next time through the loop, I'll read into the next location in the array, starting with location 0. The count variable will keep track of the next location in the array. So I'll write value array sub count equals filescanner.nextInt, and then count plus plus. I could actually increment count on the same line, so value array sub count plus plus equals filescanner.nextInt, but let's err on the side of more readable code and put the increment on a separate line. So here's the file, which has 57 as the value on the first line. When we create the scanner, it points to the top of the file. And we can think of the counter variable as pointing to the first location in the array. So hasNext will be true, we'll go into the loop, the scanner will read the 57 and advance to the next token, which is 58, and we'll store the 57 in index 0 in the array. Count will then be incremented, so we're now pointing to index 1 in the array. This will continue to the end of the file. But there's a chance there are more than 50 values in the file. The client has told us it will be a maximum of 50, but perhaps they're not anticipating future file sizes, or maybe somebody will add to the file by accident. So we will want to add to that loop entry condition so that we're not accidentally trying to write past the end of our array. We'll make the loop entry condition while filescanner.hasNext and count less than value array.length. That will ensure that we never write past the end of our array. It does mean that if there are more than 50 values in the file, we won't read them all in, but at least our program won't terminate with an exception. Now let's print the values we have stored in the array. I'll write a for loop for this, for int I equals 0, I less than count, I plus plus, and then system out println value array sub I. This loop is a lot like the loops we wrote in the last video. Our for loop control variable I will take on the values from 0 through the number of values we put in the array, and we'll use I to index into the array and print the value at that location in the array. We know that after the loop that reads the data has finished executing, count contains the number of values we've read into the array. We don't want to proceed to the end of the array, because if the array wasn't filled, there will be a lot of zeros that aren't part of the data. We refer to this as a partially filled array. With a partially filled array, we need to keep track of how many elements are in the array, and that value needs to travel along with the array so we don't accidentally process zeros or other initialization values that aren't part of the data. We could employ other strategies, like putting a sentinel value after the last data element, but for now we'll use our counter variable to keep track of the number of valid values. So my loop entry condition, I less than count, will work for this program. However, what if somebody writes some code between the two loops that changes the value of count? That would be bad and hopefully wouldn't happen, but I'd like to guard against this loop throwing an index out of bounds error. So I'm going to add to the condition in this loop as well, and make that condition I less than count and I less than value array.length. That will ensure that we don't try to index beyond the end of the array in case somebody modifies this code in the future in a way that changes count. So, to review, the I less than count condition is because the array was most likely not filled from the file, and we don't want to print the zeros that were put in the array when it was initialized. The I less than value array.length condition is some extra assurance that we won't index beyond the size of the array, which would throw an exception. Now let's do something more interesting with this data, just to review some of the algorithms and variable roles we learned in the looping lesson. This is a table of roles that variables might take on in a loop. It's a review from Lesson 4. Whether we are iterating over input entered at the keyboard, read from a file, or stored in an array, we'll still need to process each element one at a time. The variable roles we've seen are stepper, a variable that takes on a predictable sequence of values. In a for loop, the loop control variable is a stepper. An accumulator accumulates value into itself as the loop executes. It will need to be initialized before the loop. If you're adding to an accumulator, you'll initialize the accumulator to 0. A most recent holder is the current value you're looking at. In an array, that will be the next element in the array. A most wanted holder holds the best fit value so far for a property you're looking for, such as smallest or largest. This is another variable you'll need to initialize before you start comparing it to the most recent holder in the loop. Let's take our second loop, the one in which we iterate over our array, and add an accumulator to it. We'll add up all of the values in the array, and then we'll divide by the number of values we read from the file and calculate an average. I'll declare an accumulator variable at the top of the method, where I have my variable declarations, int total. Just before the loop, I'll initialize it to 0. In the loop, I'll add value array I to the total. In this loop, I is our loop control variable, the variable we're using to index into our array, and it has a stepper role. It takes on a predictable sequence of values. Value array sub I is our most recent holder. Each time through the loop, it will be referencing the next value in the array. And we're adding that to our accumulator. After the loop, we can divide total by count. Because they're both integers, I'll cast 1 to a double, so we're calculating a double division, and I'll print the result. Our algorithms that use variables in accumulator and most wanted holder roles have not changed. The only thing that might feel a little unfamiliar is understanding that our array variable sub-index will be our most recent holder, rather than a variable holding a value we just read from the keyboard or a file. And we will want to write our loop to iterate over each valid value in our array. I'm going to leave writing some most wanted holder code as an exercise for you, but if you get stumped, please feel free to drop me a comment and I'll help. In this video, we took a look at how to read data from a file into an array. To do this, we need to know the approximate amount of data so we can declare an array large enough to read the data in. As we read from the file, we'll want to check both that there is more data in our file and that we haven't exceeded the size of our array. We will need a stepper variable to index into our array so we can store the file data in the next location. Each time through the loop, we'll increment this stepper variable. When we reach the end of the file, the stepper variable will hold the amount of data we read. If that is less than the size of the array, we have a partially filled array. The stepper variable will tell us where the data ends. To sum the values in an array or find the largest or smallest value, we'll use the same algorithms with the same variable roles that we used when iterating over keyboard and file input. Our most recent holder will be the next location in the array. I hope you found this video interesting and helpful. There should be a lot here that's familiar. You just need to get used to putting it together with arrays. As usual, I've included an auto-graded exercise in the description of this video so you can practice with the video code. And the video code is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.